Okay, happy Tuesday morning. Since I will not be able to offer our typical Wednesday afternoon live online session, I wanted to at least provide this kind of a recording of the same materials available for you now early part of the week, since I know that this week will be so busy and we have a lot of ground to cover. So let's move on and have a look at a couple of things that are going to be important for this week. However, please do remember that I will still offer our Friday afternoon typical live online session. So I'm going to skip through these checking activities, and instead I want to have a look at what we've got lined up for this week. And boy, that's quite a lot that we've got to cover. So this week we're covering two chapters. We're covering chapter 6, and we're also covering chapter 7. In addition to those chapters, we will be doing our first set of exams. So let's have a look of the chapter assignments that we have, chapter homework, if you wish. I believe that most of you are already familiar with the chapter quizzes and chapter practice anatomy activities, as well as with the discussion forums. I have provided a little bit of information about the discussion forums in my announcements, so checking those announcements is going to be really important. I really appreciate all of you did rise to the occasion with, as we're kind of moving ahead, the expectations on those discussions are also fine-tuned. So rather than just doing one post, last week I asked you to do 2 posts. This week, I'm asking you to do 2 posts for each discussion forum, and the second post should be still substantial, rather than just simply posting, for example, to your friend that, oh, this was a great post, I enjoyed reading it. You should identify a little bit more, for example, why you enjoyed reading it, or build up on that post. If your friend, for example, mentions a new concept or theme, then you could share what you learned about that, or maybe that prompts you to read more into that concept, or perhaps you have a personal anecdote to share. So the purpose of these discussion forums is really to create that interaction. Like I shared in the past, our college is fiercely focused on ensuring that we don't become a correspondence course in terms of our online classes, but that there is that element of interaction. I do that by giving you quite a lot of individual feedback. And in addition to that, we create these online spaces in this discourse in form of these discussion forums. One of the assignment types that you might not be as familiar from our past that we're facing this week is going to be food for thought assignment. These are, I guess, you could describe them almost as mini essays. Uh, I'm looking for 1 or maybe 2 paragraphs. It doesn't need to be formatted like your typical English essay would be, but I'm looking for you to answer the question that's being proposed. And these questions are typically applying the information that you have learned in the chapter, but maybe in a more clinically oriented way, or maybe in somehow in a novel setting. My biggest advice for students when they're completing these want more assignments is that make sure that you answer and explore the prompt in full. It is so easy to fly through these things, and really to get full marks often in this discussion forum or discussion prompts for food for thought assignments. What I'm looking for is addressing all the things that I'm looking for. I have a grading matrix that I typically use, and probably most students enjoy that grading matrix is also made available for you. So let's have a look of that really quickly. Like I said, I'm going to jump out of the presentation, and let's go to the same view that you as a student would see. So let me share this screen with you. So now you should be seeing the exact same screen that you would see as a student. So what we have here is our course modules. So let's explore those a little bit more in detail. And we'll go to this week's chapter 6 learning module. So that's labeled as week 3A part of it. Let's have a look of this food for thought assignment. Once you open this assignment, you will actually be able to see not only the writing prompt, but also a rubric that I use to grade it. And many students find it useful to kind of orientate themselves that have I answered to all of the things that I need to answer with the help of this rubric. I use that to kind of do the rough grading first for your submission, but there is a very much of a chance that I might add additional points, or sometimes the answer doesn't fit neatly into one of the few categories that I have in the rubric. So I might need to adjust the grade that it doesn't fully fit in there based on whatever the good fit there is. But what I'm looking for is for you to engage with the material, think of the material, provide some independent thinking. And again, on these assignments, you have an option of typing in your text yourself or attaching a file that I'll have a look, whatever you prefer. But really what I'm chasing here, what I'm after is to have a submission that's substantial enough to do the needs of the assignment. So on that note, let's go back to our presentation where we were just a moment ago. And you should be able to see my screen again now. So that was our assignments for this week. Like I said, there's a lot going on. I encourage you to make a start rather earlier in the week than to leave it to the very last moment. Well, let's move on the course material and let's have a look of the kind of nutshell summary of each of the chapters that we're talking about this week. So the first chapter that we're looking at looks at the integumentary system. And one thing that I would like to highlight here is that our body is covered both inside and outside by various different body membranes. So we'll be exploring those in a little bit more of a detail. Our focus on this chapter is heavily on the cutaneous membranes, so the skin, and we'll also talk about the associated structures. However, we have other types of linings that we find more internally in the body. I think mucous membrane lining the nose, oral cavity, also respiratory system portions is a really good example of that. We have a lining of the digestive tract, also lining around the lungs. And then we have linings in various different body cavities as well that are worth of noticing. In addition, joints do tend to have their own linings. That's worthwhile to explore. So there's many different kinds of linings. I guess that's the big take-home message there. But like I said, our focus today is on the cutaneous membranes. So this provides us a nice way to connect back on what we learned about the tissue types. You see a nice histological cross-section of the skin there at the bottom of the screen. And then we'll build up on that material as well. One of the things that I think I've mentioned in the discussions already in the past, but when I initially was studying different body systems and different specialties of the medicine, I was thinking that, well, why would someone want to become a dermatologist? It's not necessarily as dramatic as being a cardiac surgeon or brain surgeon. Are you gonna be the hero who runs to the operating room and changes the path of the events? And the answer was that yes, you very much can be. Uh, Skin represents our largest organ in the body. The largest internal organ is going to be liver, but skin is the largest organ. And it, in fact, represents about 60% of your body mass. And when I think of the skin, when I think of the associated structures, and I ask why to become a dermatologist, I guess my answer would be that by treating someone who has skin disorders, you can really change the course of their life. If you're able to address those, there's a lot of to do with self-confidence and feeling good in the environment where you're at, and so on. So you can really, really do a significant improvement on the patient's life through that. What's interesting to me is that our skin, even though we all share very similar structures and very similar basic anatomy and physiology of the skin, skin is also so incredibly unique from one individual to another. And another thing that I would highlight when we're talking about integumentary system and when we're talking about dermatology is that you can tell really a lot about the patient's health simply by observing them and observing especially their skin. That gives you a lot of insight what's going on in their body. So like I said, we will be talking about skin on its own. We'll also be talking about these accessory structures like hair, nails, and various different glands. But I guess that the first question to ponder on, kind of looping into what we've been discussing about the skin, is why do we have skin? Why is it so important? And there's many answers. Skin does protect us in many different ways. Skin provides us mechanical protection against various different cuts, bumps, chemical protection against, for example, acids, bases, thermal protection against things like you could think of getting too cold or getting too warm, protection against sunlight, so UV protection, protection against many different kinds of microbes, providing that barrier, keeping things that should stay inside and keeping things that should stay outside. So that's worthwhile. And skin also helps us with maintaining our fluid balance. So preventing us from drying out, but also preventing us from absorbing what we should not be absorbing. Let's say you go to a swimming on a pool. It's not like you're a sponge and just get filled up with water. In addition to protective functions of the skin, we see that there's a lot of other things like cushioning the deeper body organs, insulating body. I would add to this list also vitamin D synthesis, which is important to go with the skin. Then also excretionary functions. So we get rid of things like urea or uric acids through the skin. So skin is very much a living structure, very much a vibrant structure. What I'm showing on this slide, I think, is largely familiar to you from our tissue chapter. So we see that skin can be divided into different layers. And the first layer that we're looking at is going to be our epidermis. And when we talk about the epidermis, what we're really seeing is that the tissue type was stratified squamous epithelia. I would notice that the outermost cells here that we're seeing are keratinized. Remember, these are dead cells, the outermost ones. So we shed about 50,000 cells all the time. So there's a lot of regeneration of the tissue taking place all the time on that level. This is actually in forensic setting why we can often find evidence left behind by the perpetrator with the cells that fall off from them. Remember, most cells, including skin cells, contain the entire nucleus and contain the entire DNA of the person. So that's something worthwhile. Other things to notice about the epidermis, I guess, is that it is non-vascular. So there is no blood supply there. So we would call it avascular structure, the outermost layers. In fact, if we study a little bit more carefully the structure of the epidermis, we will see 5 different layers that are present there. So we're moving our way from the actually innermost part of the epidermis. So from here towards the outermost parts, we'll see that the inner layer was our stratum basale. So that's the deep layer that we saw here, followed by our stratum spinosum, stratum granulosum, stratum lucidum that we will only see in thick skin, and finally the outermost layer being stratum corneum. So that's the most superficial layer of the epidermis. Another thing to notice about the epidermis is that this is where we would start to pay attention to the pigments that are present that play important role in the color of the skin, the amount of melanin, ranging really from yellow to brownish all the way to black. Obviously, we also have albinos, individuals who do not have any melanin in their skin tissue. So the next layer that I wanted to talk about is going to be our dermis. And dermis is really largely made of our collagen and elastic fibers. We see that it's the strongest and it's the thickest and most flexible layer of the skin. And this is if we think of other animals, let's say cows and rawhides, cowhides. This is the layer that we prepare the leather products from. What we will see on the dermis is the blood vessels, the glands, the nerves, and there's really two main layers that we can separate dermis into. So we have our papillary layer and our reticular layer as well. The final layer of the skin that I wanted to mention is our hypodermis. This is sometimes also referred as subcutaneous layer. And really, if we think of this layer, what it contributes, why do we have it? It anchors to the underlying structures, mostly made of adipose tissue, so fat cells and muscle, works as well in shock absorption. So those were our main layers of the skin. And if we really look at this diagram that I've been presenting to you throughout the discussion on the right-hand side and compare it to this beautiful histological cross-section of the skin, we do see the same layers. So I guess the reason why I include this is always trying to convince my students that it is not just that we as teachers love to torture our students, that no, it is very much that we try to provide you simplified representations so we can then apply those into more complex ones. I think I touched upon the color of the skin, many factors playing role in that. And we talked a little bit more earlier on about melanin in terms of controlling the amount of melanin was important for the skin color. And the ranging scale was very, very large from yellow. Albinos were what I mentioned who do not have melanin, who appear then all white tissues like skin, hair. So other factors, however, affect the color of the skin. One good example is keratin. Keratin gives you this orange-yellow color, and in fact, certain vegetables such as carrots contain high amounts of keratin. So if you were to eat a lot of carrots, if you were to eat a lot of sweet potato, it is likely that the color of the skin would change accordingly. I do live very close to BIO201, which is an Earth experiment that was conducted some time ago already, where we had 8 people living in kind of series of greenhouses isolated from rest of the world. And their diet contained a lot of sweet potato. And in fact, their skin color as a result changed during that time for that period of time. But also kind of relating to what we were discussing at the very beginning about how looking at patients' skin can tell you a lot about their health. We can see, for example, hemoglobin contributing to the skin color. So if you have really richly oxygenated blood, red blood cells, you will notice that that gives us this kind of a redder color of the skin, poor oxygenation, then kind of more of a purplish, bluish color. So that might be something that we're really looking at. We all have probably either had personal experiences or know someone who has been blushing, for example, that's a high amount of blood rushing to that part. So we can see that as well as an example of that. There are many other conditions that we can figure out and that help us to understand the color of the skin. I'll just mention here, as we're having this discussion, as one of the things, such as excessive sun exposure, which then would have negative consequences. I don't know if the wrinkles are the negative consequence, but it will definitely age the skin tones. The risk of mutations increases with extensive sun exposure, and you can end up with certain rashes. The risk of those increases if you're photosensitive. So there's a lot that we can see with the skin and a lot of factors at play. I guess what I'm trying to emphasize here is that, again, don't consider each of these systems as separate. Everything interacts with everything else. So at this point, I think it's a good time for us to have a look of those additional structures of the integumentary system. And we're going to start with the glands. So we'll talk about oil glands and sweat glands, starting with the sebaceous glands, so our oil glands. Their function, it is to produce oil that then keeps hair from being brittle and softens and moistens and kills bacteria on those. So you do want to have some oil on the surface of the skin, but especially around the hair. Typically, what we end up seeing that is that these oil glands actually open up at the base of the hair follicles. So you'll see these glands located. I also wanted to mention about the sweat glands, so some are seminiferous, pseudoferous glands that are going to be important. They, like the name proposes, do make the sweat. Remember that sweat itself is odorless. It is really the bacterial growth at these sites that where sweat is present, what that keeps the conditions optimal for this bacterial, moist, warm, that give the scent to what we consider as a sweat. The next structure that I wanted to talk about very briefly, I wanted to just show it in relation to our discussion on the food for thought assignment this week. The smallest muscle that I at least know of in the human body, erector pili muscle. Erector pili is connected to each of the hairs, and they are responsible for giving you the goosebumps, bringing the hair up if there's a need for that. And on that note, I think that gives us a good transition to talk about the hair. So hair is made at the level of the hair follicle at the root. We do have shaft portion, which is the visible portion, like we saw earlier on, very heavily keratinized tissue. Remember that hair is dead tissue, so the hair color then was controlled by really the amount of melanocytes. We can cut hair, you can get a haircut, you're not going to bleed. The growth happened, like I said, from the hair follicle. I think that that's good amount for this review session. Let's move on and talk about nails. Nails are incredibly heavily keratinized tissues. You'll see again, really nice illustration of two different parts. You'll see the nail bed where the hair, where the nail is resting on. You'll see the growth region at the root. Notice that nails do not naturally have colored, so they're non-pigmented tissue. And when we talk about the function of the nails, there's really two main things to notice. They provide a protection for the parts that ends of the fingers, ends of the toes that would be relatively sensitive for injuries. So they kind of help with protecting these parts. And in addition, they allow us to do fine grip of structures, which is something that has been a huge evolutionary advantage for human species. Moving onwards, I wanted to say a few words about the burns. There's many different sources for the burns, whether it's a heat or electric, UV radiation, chemical burn. Really, the big challenge with the burns is that we have a risk of, when we lose this protective layer, of the patient becoming dehydrated. And we also have lost this protective layer that protects us from infections. So there's an increased infection rate if there's a large burn that the patient is dealing. When we talk about the burns, we're really often estimating the extent of the burn by using what's known as a rule of nines. So in that logic, body can be divided into 11 different areas. In each of those areas represents 9% of the body surface area. And when we're classifying the severity of burns, not only are we looking at how much of the body surface area is covered with the burn, we're also looking at the extent of the burn in terms of how deep it goes. So first degree burns are just typically slightly red and swollen. Second degree burns, red. We do start to see pain and also blisters forming as a result. Third degree burns are characterized actually kind of interestingly with the lack of pain, because now both epidermis and dermis have been damaged. These ones would require a skin graft. And finally, our fourth degree burns are all the way to the bone or muscle or tendon, leaving very dry, leathery material for us, and can require an amputation as a result to address those. I did want to say a few words just briefly about the skin cancers, since we're in Arizona. Most common form of cancer in the humans, and really being exposed to UV radiation is one of the big things. Back in the 90s, tanning beds were a big deal. Luckily, I'm seeing less of that, less of people intentionally exposing themselves to that radiation. Remember when we were talking about the cancer, the C word, many patients kind of get really thrown off by that and stop listening what you're saying. So you might want to be mindful how you phrase things. You might want to talk about extensive tissue multiplication, for example. There are two main categories of the cancers. Remember, there's our benign cancers that are not spreading and malignant ones that are spreading. So that again would play an important role in our treatment of the patient and how we approach that. And that brings us to the very end of everything that I wanted to say about chapter 6. On that note, I will pull up our next chapter and we'll have a look of that briefly as well, so that we feel that we've covered everything that we might need to cover to make sure that you are well equipped to tackle this week's learning material content. So let's talk briefly about the cartilages and do a little bit of an introduction to the bone as well. So let's have a look of that. One of the things that I think is really interesting when we look at the human body and development is that early development, we don't actually have bones. We first have cartilage, and that cartilage then gets replaced with the bone tissue. If you look at these pictures that I provided here, the process of ossification has not yet fully taken place on these examples. So there's some cartilaginous matrix that will become bone and some actual bone, but the bones are not yet fully ossified. We will later on this course get to review individual bones, but this chapter is really just to kind of introduce you to the main concepts. There's really three main categories of cartilages in the body. So let's unpack that a little bit further. So the first category that I wanted to talk about is our hyaline cartilages. These are very flexible. They're also the most common cartilage types. We'll see, for example, at many of your joints, hyaline cartilage, also the costal cartilage that connects the ribs to the sternum, your respiratory pathways made of containing hyaline cartilage in high amount, and your nose tip also being a good example of hyaline cartilage. Then we have elastic cartilage, which is much more elastic than the hyaline one, as the name probably tells you. Your external ear structures would be a good example of elastic cartilage. And we also see elastic cartilage at the epiglottis, that flap-like structure that is located at the level of voice box, protecting that liquid solids don't go to the respiratory tree, they go towards the esophagus to the stomach. And the final cartilage type that I wanted to mention at this point is our fiber cartilage made of collagen fibers, very strong cartilage type. We find fiber cartilages, for example, at the knee meniscus, also at our invertebral discs, and then where our pubic symphysis is. Important structure, especially when we think of the child delivery on the females, a structure that actually deattaches during that birthing process. Normally, my students would in a class either color a diagram of these, identifying these different cartilage types, or build them out of a clay on a skeleton. So I think I have provided on your Canvas course a coloring diagram if you enjoy taking notes that way, and I'm sure you can find your own one as well if you prefer to do so. So I wanted to talk a little bit about the functions of the skeleton in this introductory chapter. So skeleton provides us the kind of scaffolding or the framework where the rest of the body is rested. If we look at that picture, if we didn't have a skeleton in our body, we would just be largely this kind of a blob-like structure jiggling on the floor. So skeleton providing that attachment points for structures such as muscles is going to be crucial. Skeleton also provides us the form of the body, protecting many structures inside. I think good examples are, for example, your brain being housed inside the skull, your rib cage protecting heart and lungs, and even your spinal cord running inside the vertebral column. So we're protecting vital stuff inside the skeletal structures. Obviously, an important role of the bones. They play close role in the production of movement. So muscles typically cross over a joint, and as they cross over a joint, we're then able to create movements in our body. This is in fact the reason why we're first talking about skeleton, and then we talk about skeletal muscles, that we can really put these together and appreciate their close relatedness to each other. We could also mention about the functions of the bone, that they play a role in storing things like calcium, salts, minerals. So large amounts of materials can be stored also within the skeleton. The role of the skeleton in blood cell formation, the production that takes place in the bone marrow, is going to be really important. The process of production of blood cells is known as hematopoiesis. A little bit of medical terminology there. The term poiesis refers to making of, and hemato refers to blood in general. This is why certain patients as well might require things like bone marrow transplants if that's something that impacts the patient. So lots to unpack there. I think that useful notes. I did want to also mention really briefly that another storage way, another role that happens is that your bones help with storing triglycerides, so fatty tissue, and also the role of the bones in hormone production. So we'll talk about endocrine system, we'll talk about that those kind of loop-like mechanisms where things are interconnected when we get to our BIO202 course. At this point, I think it's useful for us to return to a theme that we've seen before in terms of this time classifying bones into two main body regions. So this classification, which is based on location, divides individual bones either as parts of the axial skeleton, which forms the long axis of the body, so your skull, your vertebral column, and your rib cage, for example. Or bones can also be part of the appendicular skeleton, which is really the bones of the upper and lower limbs, as well as the girdles that attach these limbs to the axial skeleton. But that's not the only way of classifying bones. We can classify bones also based on their shapes. And here we describe bones either as long bones. So we see a lot of long bones, for example, at your limbs. We can talk about short bones, such as the carpal bones or kneecaps would be really good examples in of the short bones. We also have flat bones, which are characterized by being kind of a thin skull, your sternum, and your scapula would be good examples of those. And finally, we have kind of this dumping ground or catch-all category for the rest, known as irregular bones. These are really bones that don't fit into the other categories. Sometimes my students come up with really good examples and questions that, well, how would you classify this and this bone based on their shape? I will be honest that I don't think this is a perfect classification system. I think there's room for some debate in certain cases that where does the bone fall in that classification. Another way to classify bones is based on whether they're compact bone or spongy bone. So let's unbundle that. So compact bone often forms the outer layer of the bones, appears really smooth and solid, both from outside and inside. And then we have spongy bone, which is more of this honeycomb appearance, needle-like or flat pieces, known as trabeculae, that form the kind of centers of certain bones. The purpose of the spongy bone is really to reduce the weight of the entire bone while still providing structural support. Similarly, as you can see probably when you think of the metal structures that we use in construction, sometimes we have holes in those to reduce the weight, but we want to be strategic where we put those holes so that the structural integrity is not compromised as a result of that. I also wanted to talk about the structure of a bone. In this example, a long bone. We have two different parts to highlight here. We're seeing the diaphysis is really the shaft of the long bone, most of the length of the bone that we see. And then we have our epiphysis. Epiphyses are the ends. You'll notice the high amount of spongy bone within the epiphysis. And we can, on long bones, classify the two epiphyses either as one being proximal or the other one being distal. So in relation to the origin of that limb. I'm thinking, what else do we see here? Well, we see a term periosteum. Periosteum refers to this outside covering around the bone. We also see our cartilages. Articular cartilages are good examples of those covering the ends, protecting the bone ends, helping with that sliding, reducing the friction of the bone-to-bone interaction. So sometimes we see in some patients whose articular cartilages are damaged, and that would be painful and just challenging for that joint functions. What else do we see here? We can see our epiphyseal line or epiphyseal plate later on. This is the growth plate where the growth of the bone occurs during the growth stage. And we also see the cavity, medullary cavity within the long bone, especially within the diaphysis. This is where, for example, your bone marrow would be located at. I do want to highlight that bone is very much a living tissue, and we'll get into that in a bit. but there's a rich blood supply. We're constantly making new bone. We're breaking down old bone as well. What I'm showing over the series of next few slides is really different bone markings. So not only are we learning in this class the major bones of the body, we're learning major parts of these major bones. And I believe that this terminology becomes much more familiar to you as we review these with actual bones. But we do have projection sites that are really important for attachment points for muscles and ligaments. So these bumps on the surface of the bone is where muscles or ligaments connect to. We also have other projections that play important role in forming the actual joint structure. And then we have many different depressions and openings for passage of materials through the bones, such as blood vessels, nerves that pass through those, and then kind of a category of other ones that we'll also get to talk about. What I really wanted to spend the last few moments talking about the skeletal system introduction is on 3 O cell types, so 3 bone cell types. Remember, like I said, bone is very much a living material. There's constant breaking down bone and making new bone. So these cell types will help us to unbundle that. Let's start with osteoblasts. Osteoblasts are cells that are responsible for making bone, and how osteoblasts produce the bone and lay down the bony matrix is by doing so to around them, to every direction around. And what sometimes happens is that as a result, then the osteoblast gets trapped inside the bone that it has just laid out. Think of this example of someone mopping the floor and mopping around them, and they'll get stuck inside there. In this case, the trapped osteoblast that has been making new bone around themselves now becomes an osteocyte. Osteocyte is a mature, or if you wish to consider an adult bone cell. Like I said, often they're trapped inside the bone around them. They do develop these kind of parts that extend to other parts of the bone, other osteocytes through the opportunities, through the channels within that bone matrix that they have lined down. And finally, we have our osteoclasts. Osteoclasts are breaking down old bone. So in order for us to lay down new bone, we need to break down old bone. So there's this constant recycling of the material. And this is why really utilizing your skeletal system, giving it some challenge, some stress, is going to strengthen your skeletal system as well. So think of, for example, going for a jog, being physically active. You're actually strengthening the bones as you're introducing a small amount of impacts. Obviously, we don't want to go too crazy and cause damage, but that allows this cycle of O cells to lay down the bone in a new way that's going to strengthen the bone's structure. Here we see a microscopic view of the bone. You can see that we can really see that central Haversian channel and how that's surrounded by the laid down bone matrix around it. The osteon is the term that we refer to use to one of these whole structures of laid down bones. We already talked about those lymphatic vessels, nerves, blood vessels that run in these channels, perforating channels and central channels. So central channels run onto the long axis of the bone, and perforating channels then on 90 degrees from that. This is the concept that I was referring earlier on when I said that you need to give your bone some stress that allows bone to remodel to meet those stresses. So really this interplay of the O cells that helps us to maintain that. I'm not going to go into great amount of detail of the formation of the bone when it comes to the endochondral ossification and when it comes to the intramembranous ossification. I think that you can read a little bit more of that later on your chapter material, related to endochondral ossification, where hyaline cartilage is replaced. We do have primary and secondary ossification centers in this process. Intramembranous ossification, here the fibrous connective tissue gets replaced by bone. Pardon me. So really the hardening of the bone. I'm gonna finish off the review of chapter 7 by pointing out a few different classification systems for fractures. So fracture refers to break in the line of continuity of the bone. And just as you can have many different kinds of fractures, we have many ways of classifying those. If the ends of the bone remain aligned, or whether they become displaced can be one way how we classify these bones. We can also talk about the fractures. We can also talk about fractures regarding whether it's a complete one or incomplete one, only partial fracture. We can also look at things like whether the skin is punctured or remains intact, where the fracture remains inside a solid skin layer. We can also do other classification things based on whether we have multiple fragments, whether they're crushed due to the compression, whether there's twisting that breaks them, whether we break a growth plate, whether the bone gets pushed in from where it should be, or green stick one is a good example of where the bone is broken but not fully, like a young tree stick. So we see these on younger patients often. So something to keep on mind. I was going to finish off by mentioning briefly osteoporosis. But before we do so, obviously how to treat fractures depends on the type of a fracture. Typically includes realigning the ends. This can be just doctor placing them back, or it could be that we need pins and wires to secure the bone ends and then immobilizing that side so that the healing. This is where we often see the cast coming into play. So a few words about osteoporosis. Um, Osteoporosis refers to when your bones break down, so increased activity of osteoclast. That's higher than us laying new bones, so that was the osteoblasts that were responsible for that. Effects, especially women, we know that the role of estrogen is an important hormone here. So menopause causes the higher risk of osteoporosis. Lifestyle will play a role also. We typically see that osteoporosis affects your spine and neck of the femur. So these kind of more spongy bone regions. Hip fractures are another side where we see these. To really prevent osteoporosis, the big thing is to have that good intake of calcium in a diet and avoid that extensive stress, but giving enough stress to develop that strong bone. Normally with my students, I would probably talk a little bit about hip replacements, but I think this is a good amount for us for today on this review. Final thing that I'm going to do before we wrap it up for this recording, I'm going to show a little bit what to expect when it comes to the exam as well. I know students often are nervous about exams, and I don't blame you. I know many of you are pursuing degrees where having good grades for prerequisite classes is crucial. And like I said, I'm not here to catch you out. I'm here to work with you. So let's have a look of what we can expect from the exams. Well, exam 1 is going to cover 3 chapters, or chapter 1, chapter 6, and chapter 7. It's not going to be a long exam, about 11 questions. You have 30 minutes to answer those. So once you start answering, that's when the time starts. You have plenty of time to answer those. The questions in exam resemble closely what you would have seen in your chapter quizzes. So revising those chapter quizzes is the most useful thing to do. You won't have enough time that you can look up every single exam, but you certainly can look up if you have one that you feel uncomfortable and need to double check something. So this is an open book exam in case that comes you down. In terms of let's have a look of, I have a good example of here of couple of questions that could come up in the exam. I do have a mixture of different kinds of questions. For example, here we see an example of a false question. The statement says that negative feedback negates or reverses a trend. And you remember we talked about the feedback and negative feedback quite a bit. And we remember that body wanted to stay in that optimal position. So if we were deviating from that set point, negative feedback was what was responsible for, in fact, stopping that from happening and bringing us back. So this would be a true statement. A second example that we see here is please complete a sentence by choosing the most correct option. And it's asking most anatomical terms can be traced back to blank and blank. So it's asking what languages are we tracing the anatomical terms back to? And again, I think that you will notice that your quizzes would have prepared you nicely to this. Let's have a look what to expect in a practical. Practical covers the same chapters, chapter 1, 6, and 7. So we're talking about, again, things that are more kind of anatomy oriented. You've got 13 questions. In each of the questions, I'm showing you a picture, and then I'm asking you to identify what is the part of the picture that I have pointed out of a list of options. So multiple choice. You have 13 questions, 30 minutes for those, 25 points in total. Again, a single setting once you start, it time starts. It is an open book test. I don't think that you, again, need the open book. It is there if it makes you feel good. It is there if you need to check maybe one or two of the questions. But again, you won't have enough time to check all of those. But again, my students don't run out of time if they have prepared. And that really brings us to the end of this review session. Again, I'm sorry that I can't meet you in live setting on Wednesday, but we definitely will do so on Friday. As always, I am here to help. Don't hesitate to send me a message and I'll get back to you. Thank you.